start. The last class, we have discussed about the evolution of the ARM cortex. Basically, ARM, there are three versions are there: ARM A, ARM R, ARM M. And the evolution is coming to picture. Version 4, 5, 6, 7. And then it has converted into cortex M0, M1, M2, M3. Our syllabus is cortex M3. Okay. Basically, M indicates it's memory based. Okay, we need to look into how exactly ARM cortex works into picture. The architecture, it is basically an architecture. It is not the product. It is an architecture based on the type of the instruction set what we are going to use. So instruction set architecture we are going to call that one. What do you mean by that one? You may be using it as a microprocessor or you may be using it as a microcontroller. Okay, so depending on the requirement, the architecture can be designed. So it is not the product, it is an architecture designed by two different organizations. One is Apple in collaboration with Arcot. Okay, two different organizations, they have developed this particular ARM Cortex M3. Getting past, historically, ARM 7 was the most popular processor which has been developed, which has been deployed, which has been used in the market. Two different instruction sets are supported the ARM processor. The ARM instruction set, that is 32-bit, and also a thumb instruction. I was keep on telling what is the main purpose of using a thumb instruction. If ARM is a 32-bit, thumb basically it's a 16-bit instruction. Okay. So what is the main advantage of thumb instruction is it reduces the time. Execution time will be reduced because it's going to use the 16-bit only. If you go for 32-bit ARM instruction, it takes more time. But if you go for the thumb instruction, it is of 16-bit size. It is economical. It is cost effective. It is efficient, and also it's going to be fast. It's going to be fast compared to your ARM instruction. So ARM instructions that are 32-bit and thumb instructions that are 16-bit. During program execution, the processor can be dynamically switched between ARM state and also some thumb state. That is one of the major advantage of your ARM Cortex processor. Usually, I will be writing my program in terms of the 32-bit instruction, but whenever you feel that 32-bit is not required, we have to go for 16-bit only, then we can switch over to thumb instruction also. So basically, in other processors like microprocessors 8085, 8086, we were not having this switchover operation. We were using, if it is 8-bit register, we have to use throughout the operation, we have to use 8-bit only. If it is 16-bit register, whatever may be the data you are going to have, you are supposed to use 16-bit register only. Even though data is 8-bit, we are using 16-bit register. It was consuming more time. Correct? No. Okay. See, I'm having my data is only 8-bit. If I want to deal with those 8-bit data, if my microprocessor 8086, if it is 16-bit processor, even though data is 8-bit, I have to use 16-bit register itself. It is consuming more memory, it is consuming more time over there. It's like remaining 8 bits what we are adding, we are supposed to pad them with zeros. We have to fill them with zeros itself. Otherwise it won't work. But when you go for ARM Cortex, even though normal register size is 32-bit register, whenever you feel that one, I am handling only 16-bit data, no need to go for ARM registers or ARM instructions. You can switch over to thumb instruction itself. That's the main advantage of doing that. Okay. Thumb state to use either one of the instruction set. Either we can go for the ARM instruction set or we can go for the thumb instruction set. Any doubts here? Okay. So based on the type of the data you are handling, either you can go for ARM instruction or you can go for thumb instruction over there. So obviously it's going to be advantage over there. Okay. The thumb instruction set provides only a subset of ARM instruction, but it can provide the higher code density. Obviously, because the time taken is very less, the memory utilization is very less, where we can go for more code into that one. More operations can be executed when you go for the thumb instructions. I am still talking about the thumb. I am not yet come to the Thumb2 instruction. Okay, we are just discussing about the what is the ARM instruction, what is thumb instruction. Later we will switch over to Thumb2 instruction. It is useful for the products with tight memory requirement. Obviously, whenever the memory is very less, whenever you don't want to use more memory, tight memory requirement is there. At that time, we are going to use the thumb instruction itself. Chandana, sumne kutkobeku. As the architecture version has been updated, obviously ARM4, ARM5, ARM6, ARM7, then it has come into Cortex. Okay, so architecture is getting updated. Extra instructions have been added. You usually, initially, simple example is your calculator. When you look into, I told you an example of calculator where when we were using the calculator some 20 years, 25 years back, at that time we are not having the trigonometrical operation at all. Okay, we are not having trigonometrical. Now we are having the trigonometrical operations. You are having over there. So, and now we are having the binary to octal, octal to this one hexadecimal, all those things. We were not having all those options. Okay, we were having only arithmetic and arithmetic only we were having over there. So, trigonometrical operation was not at all there. Now, as the architecture advanced, as the technology is changed, they have added the new instruction. Trigonometrical instructions have been added. Memory has been added over there itself, where you can go back and you can modify your instruction. You can execute that. So, as the architecture version has been updated, extra instructions have been added to both ARM instruction and also thumb instruction. In 2003, ARM announced the Thumb2. That's what I am telling. Till now, we were having only thumb instruction where ARM is a 32-bit, ARM instruction is the 32-bit, thumb instruction is only 16-bit. But in 2003, they were introduced Thumb2 instruction, which is a new superset of thumb instruction that contains both 16-bit and also 32-bit. So major advantage of Thumb2 is it can deal with the 16-bit data also, it can also deal with the 32-bit data also. Previously, what we were having thumb instruction, it was mainly used for 16-bit operation. Now, Thumb2, they have introduced where based on the requirement, we can go for 16-bit or we can go for 32-bit. Let us move ahead. Thumb2 technology extended the thumb instruction set architecture, that is ISA, into a highly efficient, I told you, what are the main advantage of that one? Highly efficient and powerful instruction set that delivers significant benefits in terms of the easy to use, code size and performance. Code size means code density. You can increase the code, how much ever code you want, because I'm dealing with only 16-bit data. It is occupying the 50% less memory, so I can go for more instruction. We can go for it. The extended instruction set in Thumb2 is superset of the previous 16-bit thumb instruction set with additional 16-bit instruction along the 32-bit. That is the same thing has been repeated. It allows more complex operation to be carried out in the thumb stage. Example is your calculator. More complex operations what we were not able to do previously, now we are able to do all the complex operations like your trigonometrical operations. Okay, allowing the higher efficiency by reducing the number of states switching between the ARM state to thumb state. Same procedure. We were doing ARM, we want to switch to the thumb instruction, we can switch. We are doing thumb instruction, we can switch over to ARM instruction also. So this is the architecture, very simple architecture. As you will see, we are going to have thumb 16 instruction, 16-bit. Previous version of thumb instruction is only 16-bit. Now, Cortex M3 has been added with additional 32-bit instruction and also there is Thumb2 where it can deal with the 16-bit data also, it can deal with the 16-bit instruction or it can also deal with the 32-bit data or 32-bit instruction itself. See, previously ARM version 7M, ARM version 7M architecture, we call them as Cortex M3. Okay, ARM version 7 was there, but they have added M into that one. That is M3 is the architecture. The relation between the thumb instruction set and Thumb2 technology and the traditional thumb. So this is the traditional thumb, which is 16-bit, and added one, newly updated one is a Thumb2 instruction set architecture, which deals with the either 16-bit data also, 32-bit data also. Next, Cortex M3 supports only the Thumb2 instruction set. and traditional thumb. It can only Thumb2 also it can go for Thumb2 in the sense it can go for both 16-bit and also 32-bit is there. Instead of using ARM instructions for some operations as a traditional ARM processor, it uses Thumb2 instruction set for all the operations. So previously we were switching over from ARM to Thumb to ARM based on the requirement. Now we can directly go for the Thumb2 instruction set itself. We can go for it. As a result, the Cortex M3 processor is not backward compatible with traditional ARM processor. Okay. With the support of both 16-bit and 32-bit instructions in the Thumb2 instruction set, there is no need to switch the processor between the Thumb state and also ARM state, because Thumb itself can support the 32-bit, Thumb itself can support the 16-bit, both it can support. I can perform the 32-bit operation using Thumb2 instruction set itself. I can perform the 16-bit also. Okay, single person can take two different subjects. No need to have the two different person to take two different subjects over there. Same person can take both the subject depending on the requirement. He can take the third semester, he can take the fifth semester. He can take the fourth semester, he can take the sixth semester. So like that only, a Thumb2 instruction set, it can perform both 16-bit data, it can perform 32-bit data also. In a Cortex M3 processor, 32-bit instructions can be mixed with 16-bit instruction without switching state. Same statement, they are given the different format itself. Okay, I can switch from 16-bit to 32-bit, 32-bit to 16-bit. The Thumb2 instruction set is a very important feature of the ARM7. So applications, why? When we are having all these advantages, where and all we are going to use the Thumb2, or where and all we are going to use the Cortex M3. First and foremost is, obviously, whenever you go for a new technology, when you are using, basically we look for whether it's a costlier or it's a low cost one. So whenever a new technology has been introduced, they should not blindly prepare that one or use that one. They should not say that one is very costly. Usually nowadays what's happening, all the new technologies what we are having, especially with respect to our electronic gadgets, okay, as the technology increases, they say that one cost also increases itself. Okay, but once the core of the any electronic equipment, if it is developed, a new technology has been used, they should see to that one, can we use that one everywhere? Can we use that one to low cost application? Can we use that one to high cost applications also? So Thumb2 instruction set what we are using in Cortex M3 processor, it can be used for low cost microcontrollers. First application. Cortex M3 processor is ideally suited for low-cost microcontroller which are commonly used in consumer products from toys to electrical appliances. I told you a simple example is your phone, toy phone. Similarly, a talking Tom. So all the toys what we are having nowadays, video gaming. You may be having video gaming over there. So all those things they will be, they are very very low cost, economical, because they have to reach the market. Basically, whenever the new product has been released, they have to see to that one, they should reach the large market over there. When they are reaching the large market, obviously they have to look for the what is the cost of that one. If they reduce the cost, definitely they can reach the large market. If they reduce the cost, definitely they can reach the large market over there. Example is your Android mobile phone and Apple mobile phone. Okay, Apple mobile phone. When I just count in the class, out of 60, maybe 10% may be having Apple mobile phone. Remaining 90% will be having the Android mobile phone. Is that true? Yes or no? How many of you are having Apple mobile phone? Okay. I'm able to get only 2 names. Any other name? 3. Okay. Out of 50, 3 of you are having Apple. Remaining all are Android only. All are Android. So Android, they're low cost compared to the Apple. Correct? No. So your microprocessor are on Cortex M3, which is developed with Thumb2 instruction set, it should reach the large market where cost supposed to be less, economical. It's not too less, it's not too cheap, it should be economical. Everyone can afford that person. Cortex M3 processor is ideally suited for low-cost microcontrollers, which are commonly used in consumer products from toys to electrical appliances. Even household appliances, whatever you are going to have that one. You might have heard about IFB. IFB, what is IFB? Washing machine, Whirlpool, correct? Whirlpool, these are the two major companies with costlier washing machines are there. Any other companies are there which is costlier or which are producing the washing machines? Bosch, LG, Samsung, Godrej, Videocon. Okay, these are all the electronic companies where they are producing the washing machine. Listen, they are using the processor. Some of them may be costlier, some of them may be cheaper or economical. So it should be suited for both the type of applications. I am just giving the example of mobile phones and also washing machines. Like this, we are having n number of applications or electrical equipments which are available. They are using the microcontrollers and microprocessors. It is a highly competitive market due to the many well-known 8-bit and 16-bit microcontroller products on the market. Obviously, already in the market, there are so many electrical equipments which are there. They are using the 8-bit microprocessors and 16-bit microprocessor, but when they introduce the new one, it should also support the older version. It should also support the older version. It should not say that one old one is outdated, I cannot support. It should support the existing one and it should also support the new one itself. Its low power, high performance and easy of use advantages enable embedded developers to migrate to 32-bit system and develop products with the ARM architecture. Obviously, new technologies, new innovations, new requirements comes into picture, which should enable them to go for the new applications, new type of the operations. That is the first type. Low cost applications is the first application of your Cortex M3. Second one is data communication. Second field, second type of the operation field comes into data communication. Data communication is your mobile phone where you can communicate the data, okay, or it may be a broadband. It may be data communication, you want to communicate, it may be internet, any type of the application which is trying to communicate the data. The processor's low power and high efficiency coupled with the instructions in Thumb2 for bit field manipulation make the Cortex M3 ideal for many communication applications such as Bluetooth and Zigbee. Say, it may be wired communication, obviously wired communication existing since many decades, but wireless communication comes only 10 to 15 years back, okay, or 20 years back. Since 60 to 70 years, we are having wired communication. But when you want to go for the wireless communication, we're supposed to use the new processors and controllers where we are going to use the Thumb2 instruction set for Bluetooth and Zigbee. You should know what is the communication coverage area for Zigbee, what is the communication coverage area for Bluetooth. Bluetooth coverage area. What is the distance, maximum distance it can cover? Bluetooth, 10 meters, 20 meters. Have you ever tried it out? Connecting to Bluetooth devices and moving away from that one, tried? Maximum 10 meters you can go for that one. Zigbee, not tried. Okay, Zigbee also, it cannot go for beyond 10 to 20 meters. It is within the limit only, you can go for it. So that is one of the major application. Any data communication you want to do that one, you can use either my Cortex M3 Thumb2 instruction set architecture you can use and you can go for communication. So it's the best way, best application where we can go for transmitting the data and receiving the data. Third one, very important, automotive applications. Example is your autonomous vehicles. Autonomous vehicles, you heard about it? Autonomous vehicles. Yes or no? No idea. A vehicle which can operate on its own. Tesla is one of the company Okay, driverless car, we call that one. Okay, that is one very big example. It is very big example. But nowadays, very simple example is, if you are not, listen, as soon as you sit in the vehicle, assume that one your four-wheeler, and use ignition is on. Vehicle, you're, you're in the driver's seat, your ignition is on, immediately you're going to get a siren. What may be the reason? A siren comes from the vehicle itself. What are the different reasons where you are going to get the siren? Seat belt is, you're not wearing the seat belt properly, it's not fixed, seat belt is not fixed, door is not locked, door is not locked. Okay, these are the major two indicators. Fuel, fuel also, fuel, if the fuel is getting empty, new technology where everywhere they are using the your processors, where automatically it's going to indicate the signals for you itself. Automatically it's going to give the signals. As soon as you apply the brake, okay, indicator should be on. Is that so? Two-wheelers generally, two-wheelers or any vehicle, during the morning also it's going to, if you apply the brake, will it, light will be ignite? Indicators, back indicators, okay. I'm not telling your microprocessor is going to be there. New technology is going to incorporate such a way that one, if your door is not locked, it's going to give the signal. If the belt is not fixed properly, seat belt is not fixed properly. Nowadays, both front seat belt should be fixed over there itself. Previously, it was only for the driver. Now it is even the person is sitting beside the driver also. Later, it may come for everyone. It may come for everyone. Everyone should fix the seat belt properly. Otherwise, it's going to, it will be there. So, automotive, the Cortex M3 processor has very high performance efficiency and low interrupt latency, allowing it to be used in real-time systems. Automotive is always real-time system. Automotive is always real-time system, especially a vehicle on road, on water or in water, okay, under the water or in the air, they should always perform real time. I have given n number of applications with respect to real time. Taking off, takeoff, aircraft takeoff, aircraft landing is one of the best example. Okay, recently because of elections, many leaders, political leaders, they are using the vehicles, air vehicles they are using over there. Okay, nowadays everyone is using that mindset. So each and every operation in the air vehicles supposed to be real time. Supposed to be real time. On road you can have some latency. Okay, but if it is air vehicle, there should not be any, even a small 0.0001% latency should not be there itself. Okay, so Cortex M3 works with nanoseconds. It's going to give you the high performance without any latency, without any delay. Cortex M3 processor supports up to 240 external vectored interrupts. It's saying the interrupts, all those interrupts can be supported with a built-in interrupt controller with nested interrupt support and an optional MPU, okay, microprocessor unit, making it ideal for highly integrated and cost-sensitive automotive applications. So when it comes to application side, I'm going to explain in depth, in detail, which application using what type of operation. Okay, when it comes to interrupts. The fourth type is industrial control. Now all the industries are automated. All the industries are automated. No manpower is required. Once you switch on, it is 24/7 only. It's working over there. So only just give the raw material and take back the final product. Manpower is required. In between, whatever the operations is happening, everything is automated in the industries. Car manufacturing, vehicle manufacturing, whichever it is going to be, everything is automated. Only robots are taking care of that one. Okay. So industry control applications, simplicity, fast response, and reliability are key factors. Okay. Manikanta, concentrate here. Again, the Cortex M3 processors interrupt features, low interrupt latency, and enhanced fault handling features make it a strong candidate in this area. Any faults comes into picture, fixing the product. Every product is automated only. Every product is automated. Industries are automated. So manpower is losing the job, but efficiency comes into picture. 100% efficiency. If I want to fix a screw firmly, man, if he is fixing the screw firmly, it takes time for him and he may not fix it properly. But if you give the same thing for the automated machine, it fixes it firmly, efficiently, with a high speed, it's going to do that myself. Okay? So industries are major requirement of your microcontroller and microprocessor. ARM Cortex M3 is going to be used. Consumer products, all the products what we are using now, right from your wristwatch, everywhere we are going to use the processors. In many consumer products, high performance microprocessors used. Cortex M3 processor being a small processor is highly efficient, low power. See, obviously, what are the advantages of Cortex M3? If you see, low cost, high efficiency, and low power consumption. These three, if you give now, you'll get the marks. Okay. Advantages. When it comes to application, we'll look into the advantages: greater efficiency, performance efficiency, low power consumption, enhanced determinism, improved code density. That is one of the advantage because you can go for the more code, easy to use, lowest cost solution, wide choice of deployment development tools. So these are the 1, 2, 3, 4, 5, 6 advantages, 7 advantages of your Cortex M3. Even you don't know technically what are the advantages, you can give efficient, low cost, and also low power consumption. These are the three factors. Definitely you'll get the 3 marks over there. So you should give the explanation for that one. What do you mean by low power consumption? Okay, if you know the statistics, you can get how much power it's going to consume over there. Okay, what is the cost? Cost also you can mention that. So greater performance efficiency allows more work to be done without increasing the frequency or power requirement. I don't want to increase the power requirement, increase the power. Say my fan need to run. If it has to run fast, I should increase the power. Okay, that doesn't require for your microcontroller ARM Cortex M3, where it can perform the improved efficiency, improved performance without the increase in the frequency, without increasing the power. Low power consumption enables longer battery life, especially critical in portable products. Your any batteries powered application, battery powered applications, it may be your smartwatch, it may be your mobile phone, it may be any type of the devices which is operating in the battery, they consume less power. Where critical time requirement is there, it can work for that. Enhanced determinism, okay, it can give more quality, guarantees that critical tasks and interrupts are served as quickly as possible and is known as the number of cycles. Less number of cycles going to use to execute the product. It's execute the instruction. Improved code density, I already told, easy to use, low cost solution, it uses less cost, wide choice of development tools. So we have discussed what is Thumb2 instruction, what are the advantages of Thumb2 instruction, what are the different applications of them, various applications of Cortex M3, there are 5 applications have been given, and what are the advantages of that one. Now we need to go for how exactly it is there inside the Cortex M3. What are all the different types of architecture, it is a single architecture only, different parts are there in your Cortex M3 architecture. See, the main block, big square block, indicates the Cortex M3. Inside that one, we will be having a register bank, we will be having ALU, we will be having decoder, instruction fetch unit, interrupt controller, debug system, memory interface, memory protection unit, bus interconnect, debug interface. All these put together is a Cortex M3. But the Cortex M3 is externally connected with the code memory, memory system and peripherals, and private peripherals. And we will be having the optional slot also where we can extend that one to different types of peripheral device can be connected. Almost all the processors, they will be having ALU, arithmetic logic unit it will be having interrupt controller. Any interrupt comes into which it will be having interrupt controller, memory interfacing. See, memory interface, it has to connect a memory means there should be an interface and it should be connected to peripherals. The peripheral interface also is there. Different types of peripherals we are going to connect. It may be high speed peripheral, it may be low speed peripheral. We need to connect them. So peripheral interface, that is bus interconnect, we will call that one. Debugging interface. Debugging interface, if anything need to be debugged, we are going to use the debugging interface also. See, we have two different types of buses. One is instruction bus, other is the data bus. What do you mean by that one? All data which is available in your system, they will flow through the data bus and instructions will be used, the instruction bus to execute, to send that one to the peripherals and also other devices. Cortex M3 is a 32-bit microprocessor. Processor has the Harvard architecture. Have you come across Harvard architecture? Yes or no? Van Neumann architecture, CO. Have you studied CO? Have you COA? Have you studied that? In that one, there are two types of architectures have been explained: Harvard architecture and Van Neumann architecture. Yes or no? Yes, I know. It is there. When a system, when a processor is there, processor can be Harvard architecture, it can be Van Neumann architecture, or it will be one more architecture is there. Okay. So your ARM Cortex M3 is a Harvard architecture, which means that it has a separate instruction bus and data bus. The bus here, it shows separate bus for instruction, separate bus for data. So Harvard architecture means it is having a two separate buses, two separate memory also. One memory for data, one memory for instruction. But Van Neumann architecture is not like that. Same memory is used for your data and also instruction. This allows instruction and data access to take place at the same time. The performance of the processor increases because the data access do not affect the instruction pipeline. This feature results in multiple bus interfaces on Cortex M3, each with optimized usage and the ability to be used simultaneously. However, the instructions and data bus share the same memory space. Okay, same memory space it's using. Harvard architecture uses the same memory space. Van Neumann is going to use the different memory space. For complex applications that requires more memory system features, the Cortex M3 processor has an optional memory protection unit, MPU, memory protection unit, and it is possible to use an external cache if it is required. Cache is very closely, tightly coupled memory, we call that one. Cache is tightly coupled memory where it can be executed fast. It can be executed fast. That's why we are going to use the cache, and the size of the cache is very, very less compared to your main memory. Main memory it will be in GB, your cache memory is in KB. Okay, both little endian and big endian memory system are supported. I think you have come across what do you mean by little endian and big endian. The Cortex M3 processor includes the number of fixed internal debugging components. These components provide the debugging operation supports and features. So whatever was there in the block diagram, it is being explained here. In addition, we are going to have the optional component port where we can connect different external component we can connect over there. Three-stage pipeline. I told you already, pipelining instruction: fetch, decode, execute. Fetch, decode, execute. These are the three stages. It's going to be used pipelining, where I don't want to wait until the first instruction is going to be completing its operation. Once the first instruction is fetched, it sends to debug. Second instruction can be fetched over there. So where I can reduce the number of cycles, we can reduce the number of time required for execution. Harvard bus architecture with unified memory space. Instructions data use the same address space. 32-bit addressing supports the 4 GB memory space. AMDA bus. It uses the AMBA, Advanced Memory Control Bus Architecture. We call this as AMBA bus. Advanced Memory Control Bus Architecture it's going to use, which allows pipeline bus operations for higher throughput. It uses the pipelining operation where you're going to get higher throughput. An interrupt controller called NVIC, Nested Vector Interrupt Controller, supports up to 240 interrupts requested and from 8 to 256 interrupt priority level. Maximum 256 interrupts can handle. Supports for various features for operating systems such as system tick timer, shadowed stack pointer, everything it can be. Sleep mode support, it supports the sleep mode also. Supports for an optional MPU, its MPU is optional. Supports for bit data access in two specific memory regions using the feature called the bit band. The option of being used in single processor or multi-processor designs, it can be used over there.